Alright, so today we're going to look at inequalities and solving them, and then key things to look for when solving them, as well as going over some examples and um, graphing these linearly on a line, and possibly using set builder notation. I will touch up on that just so that for students that have seen it, it's a good reference, and if you haven't seen it, you will eventually see it, if not now. So, solving inequalities, there are very similar to equations, but instead we deal with symbols such as less than, greater than, then we have a combination of less than or equal to, and greater than or equal to. Now, there are certain rules that apply when we are working with inequalities. If we ever multiply or divide the inequality by a negative value, we must switch the sign. So, for example, if I had started with this guy right here, the less than sign, and I have multiplied both sides of my equation, or inequality, I guess, just to be precise, by a negative value or divided by a negative value, in the end, after I do the arithmetic, I must change the sign to a greater than sign. And the same, vice versa for this one. If I started with that one, then multiplied by a negative value, then we would have to swap over to the other one. And that's essentially the only trigger that we really have to keep in mind. Now, when when um when working inequalities, the idea is the same as applying those 7 equality tools that we discussed in the previous section. All of that applies when we're solving our inequalities. So make sure that you're very familiar with that before we begin with inequalities, because there's just a little bit more, a few more extra steps. Alright, so we'll begin with just solving, going over an example, and then we'll tackle the various things that I'd like to point out. So we have, in this example, 8x plus 9 is greater than or equal to negative 15. Ooh, doesn't seem like you can see that pretty well. I don't think I tried this enough. So let me try it again. 8x plus 9 is greater than or equal to negative 15. Alright, so we'll begin this problem just as every other problem, any other equation that is. We want to isolate the variable, so we have a constant and a constant and a variable with a coefficient. So we'll begin by subtracting over the constant to both sides, so we can isolate the variable. So we see that this cancels out. Negative 15 minus a 9, so we're going further away from 0 in this by doing this, and we get 24, negative 24. We have 8x just gets dropped down below. Now, next we want to divide both sides, and that's one of the solving tools, the equality solving tools. We'll be able to divide over by 8. Therefore, we get x is greater than or equal to negative 24 divided by 8. That gives us negative 3. Alright, so now we solve this. And now, the reason that differs between an equation and inequality is that an inequality holds for specific values, or it doesn't hold at all. So, whereas an equation, either it holds or it doesn't. So, in this one, we develop like a set of numbers that can satisfy this equation. And I will illustrate it below. So, imagine now we'll move on to graph this on a number line. So this is saying that x is greater than or equal to negative 3. So first we begin by just rendering our graph. We locate -3, and now we want the value x to be, x can vary from any value that is larger or and equal to -3. So usually this is the equal is represented by a bracket. Now because we want every value that is larger than -3, we will shade everything to the right. Okay? So you see everything to the right can suffice. So for example, one of these values that we can just look at to check if this is true, we can plug in 0. We have 8 times 0, that gives us 0, plus 9, so we have 9. Is 9 greater than or equal to -15? 9 is definitely larger than that, because 9 is positive, and any positive number is larger than a negative number. So this holds. Now, to move up from this part, we want to express this in set builder notation. So usually how I look at set builder notation is I just kind of follow along the graph and I see where it begins and how it ends. And if there's any breaks, which will, if you haven't seen now, you will eventually see. So moving right along, I see that I start at -3, and because this is a bracket, we will also contain a bracket. So we start at -3, and just see that anything that above that will be a solution. And this line could extend infinitely. So it can be, we can express this in in set notation as -3 to infinity. And then we end this with a parentheses. Now, a parentheses around the infinity is because we can't really necessarily attain that number. We don't know what that number is, but we know it's an extremely large number and it keeps on expanding. So, which is why we put a parentheses over it. Whereas the bracket indicates that this value is included in our set. So -3 is a number that we can obtain. It's expressed on the number line, and it's included in our graph, which is why we use a bracket.